Hi, engineers. Today we are going to see interference in thin films. We will take one plane, top plane, and this one a bottom plane. So top plane will be x prime, bottom plane will be y prime. This is the thin film with thickness t and refractive index mu. Now, whenever light ray comes here, it will fall on the surface. This is a starting point A, we can assume. There is a two chances. One, with respect to the normal, the light ray will get reflected into the air. This is the air medium. Or it may get into thin film. So whenever it is getting into thin films, this is a denser medium and the air is a rarer medium. So it will move towards the normal. So rather than traveling straight line, it will move and get fall here. Here also two things happen. One is it will get reflected from here or it may get transmitted. So we are considering only reflected scenario. So when it started A, when it falls here B, and the reflected ray is C. When it transmit into the film, here it is D. Then whenever it fall here, it will get chances somewhat it will get reflect. So whenever it come out, it will make same parallel line with that one and it will go out. So if it is D, E and F. So this is the path of light rays. Light rays comes here, it will bend little here, fall on the bottom surface, then it will get reflected. Based on this, we have to calculate the path difference. So for that purpose, we have to show different angles in the picture in order to calculate. So whenever light is falling on the top surface, this is the incident angle and this is the refracted angle. This same angle is equal to here and this will be equal to here. Based on laws, we have to draw a perpendicular to the surface and we have to calculate the path difference. How much difference is there? This one as a P. Whenever light travels, this is the one path A, B, C. And another path is A, B, D, E, F. So here our main motive is to calculate the path difference. That's in order to get the constructive and destructive interference. So path difference will play the key role. We have to calculate path difference. How to calculate simply the path difference. It will be equal to mu into BD plus D. Mu is the refractive index of the film into ray path it covered. So mu into BD plus D, that is the path BDE in the film, minus mu air and BP. BP means the distance it covered. Now we have to calculate these two values, BD, DE and BP. So in order to calculate these parameters, we use these triangles. So in order to calculate the BD, we use BDQ. In order to calculate DE, we use DQE. Then in order to calculate the BP, we use BPE. So three triangles we will use and we will calculate the concerned parameter. Triangle BD. This is the triangle. At Q we have the right angle. QD is nothing but thickness of the film. R is there. Cos R. Cos gives adjoint side by hypotenuse. That is adjoint side is QD by BD. BD can be written as T by cos R. So similarly, we can get DE as T by cos R. Now we can add both BD plus DE equal to T by cos R plus T by cos R. That will give simply 2T by cos R. This is BD plus, this is we can treat it as a second one and that actual one, whatever we are supposed to substitute, we will treat this equation as a 1. Right? So we used the two triangles for BD, BDQ and DE, DE. We will get that one. Now we have to calculate the next part. Next part is what? That BP we have to calculate. So in order to calculate BP, we have to take BPE. So what we have to do is here for BP, we will take triangle BPQ. So whenever we take a triangle BPQ, that will be like this. The triangle BPQ, the right angle is at P, that angle is at E and this is a B. So at P it's a 90 degrees, it's E, it is I. Now we will calculate BP. So it is a opposite side, we have to use this one. So here what we will do is opposite side by hypotenuse we will use. So we will write sine I. Sine will give opposite side by hypotenuse. Opposite side is PB by B. That is BP by PE is nothing but PQ plus QE. So here we will write BP equal to PQ plus QE into sin I. Now we have to calculate BQ and QE and then substitute in this expression. So from where we will get BQ and QE? If we observe the graph carefully, this diagram, PQ, QE. So in order to get that one, we have to use BDQ and QDE. So those two triangles we will use. So here we will write for BQ. In order to get BQ, we will use triangle BDQ. So in a triangle BDQ, what we will do? We will calculate a tan R. So tan R will give BQ by QD. That is BQ we will get as T tan R. So we can see the image how the BDQ look like. So as shown in the figure, we can get the BQ is equal to T tan R. Tan gives opposite side by adjoint side. Similarly, from the triangle DQE, we will get again tan R on the same line. Tan R is equal to QE by QD. QE equal to T tan R. Therefore, we can calculate the BP. Now, BP is equal to BQ plus QE. So that will give T tan R plus T tan R. So T tan R. If we see BQ, here sin I is there. So we have to add the sin I. And we know that from Snell's law, we can write refractive index mu equal to sin I by sin R. Means incident angle we are converting into sin I is equal to mu sin R. So this one we will replace in the above expression and that will leads us BP equal to 2 mu T tan R sin R. So this BP we got now. BP value. This is equation number 3. Now finally we have to calculate the path difference. So initially we wrote as path difference equal to the path difference delta equal to, we wrote that mu into BD plus DE minus mu air into BP. So once we substitute all these values here, we will get 2 mu T by cos R minus 2 mu T sin square R by cos R. What we are supposed to do is we have to simplify this one. Now we have to take 2 mu T by cos R as a common, then it will be 1 minus sin square R. So if it is 1 minus sin square R, that can be written as simply cos R into cos square R. We already know sin square theta plus cos square theta is equal to 1. From that relation we will use. So we will cancel this one. What we are left with finally 2 mu T cos R. So this is the path difference. And this is also known as cosine law. So this is also known as cosine law. Now if we observe the diagram, the light ray get reflected from the top surface at the point B. So whenever it reflection occurs from the upper surface of the thin film, the light ray BC goes an additional phase change of pi or additional path difference of lambda by 2, right? So additional path difference of lambda by 2 will takes place there by Stokes theorem. So here we will write that statement and we will modify this BP value. So this is the cosine law. Now what we are going to write is from Stokes theorem. So what the Stokes theorem says, at point B, reflection occurs from the upper surface of the thin film. So the light ray BC undergoes an additional phase change of pi or path difference of lambda by that takes place only surface. Then the total path difference including this condition. So total path difference we will get delta prime or delta we can write, no problem. 2 mu T cos R minus lambda. Some textbooks they will use plus or minus, but you can take minus lambda by 2, no problem. Then we have two cases. So based on this path difference, we have two cases for constructive interference and destructive interference. So we will see the case 1 where we will get the maximum intensity. So for constructive interference, so whenever constructive interference takes place, their bright fringe will form, and whenever destructive interference will takes place, dark fringe will form. So what happens is in the constructive interference, the path difference should be equal to n lambda, where n takes the values 0, 1, 2, 3, like that anything it can take. So we have to equate simply condition to this one. 2 mu t cos r minus lambda by 2 equal to n lambda. So once we equate n lambda, we will get this condition 2 mu t cos r equal to n lambda plus lambda by 2. That one we can take lambda by 2 as a common. So it will become 2n plus 1 into lambda by 2. This is condition for maxima. So 2n plus 1 into lambda by 2, 2 mu t cos r equal to 2n plus 1 into lambda by 2. This is for condition for maxima. And film appears bright. Destructive interference. There path difference equal to, it should be for a destructive interference, the path difference should be, it's a odd multiple of lambda by 2. Now we have to equate this condition. 2 mu t cos r, whatever we got the path difference, effective path difference, that one we have to equate to 2n plus 1 into lambda by 2. Then we will get 2 mu t cos r equal to, so it will be 2n lambda by 2 plus lambda by 2 if we multiply it, then plus lambda by 2. If we bring that minus lambda by 2, it will become plus lambda by 2. On overall simplifications, it will be became simply n plus 1 into lambda. So where n takes the values 0, 1, 2, 3, like that. Now, what we will do is, since n is integer, n plus 1 is also taken as integer. Therefore, the condition for minima will be 2 mu t cos r equal to n prime lambda. Just we replaced n prime as n plus 1. So this is the condition for minima, and film appears dark.